All right, CNT125, we're on our voice over IP module. So we just got done talking some history. Now we're going to start working into some, IP phone modern kinds of thoughts or technologies. So when we start talking IP phone today, there's usually a term unified communications is kind of the umbrella for anything IP phone or IP video related. So you'll see that terminology used pretty regularly. Now, we do need to remember our traditional phone system was your PSTN, Public Switch Telephone Network. Your traditional phone system was a circuit switched model that carried your phone calls. Circuit switch meaning when you dialed that phone and literally the relays connected one to the next, to the next, to the next, it was building an electrical path from your phone to the person you're calling's phone. And that electrical circuit was in place when you talked and stayed in place until you hung up, and then all those relays kind of reset and opened that circuit up for somebody else to use. So it literally was building a circuit for all of my phone traffic to go directly to them and from them back to me. And when we were done, we closed down. So that's your circuit switch networks. Our modern networks like Ethernet is a packet switch network. That's why we talked early on about OSI model and having data segments, packets, frames, bits. With our Ethernet or modern packet switch networks, we take whatever we're sending, break it into pieces, and put little headers on, and those pieces get sent into the network, and we kind of push them out there. We're like, well, good luck, hope you get there. And all the devices, your switches and routers, read those and move them to the destination. The destination gathers them all and starts putting them back together and feeding them to the recipient. Well, as long as those packets move quickly enough, it doesn't matter with my voice. As long as I chop them up, address them, and move them quickly through the network, they'll get to the recipient, put back together, and we can receive them. Well, early on Ethernet networks that did not have a lot of bandwidth, this was problematic for voice. It was very, very choppy, and your voice quality was pretty low. With the high bandwidths we have today and the much better reliability we have today, that's not really an issue anymore. We can move these packets across frequently, and we can even do what's called quality of service, where we hold other traffic back and let the voice traffic through first. Kind of like, okay, we're going to send a couple voice packets through, then we'll send a chunk of data. A couple voice packets through, then we'll send a chunk of data. So our networks can handle this traffic so much better than it used to be able to. And that's the kind of stuff that I literally have over here. The greatest advantage of packet switching, it doesn't waste bandwidth by holding that circuit open, even if it's not using it. We have mechanisms like quality of service that can replicate that type of circuit switch, but also mingle it with other pieces of data moving through. Ethernet's our most common example of packet switching. And unified communications user can access anything voice related we can think of, including video, and even potentially some web-based stuff as well. Browse in and get your messages and so forth. I do that pretty regularly myself. IP telephony, that's kind of, again, a umbrella term. Any network carrying voice signals using TCP/IP, public or private. And it's typically packet switch network that we're dealing with. The type of connections that can carry voice or IP signals, well, it's pretty much every type of network connection now can carry voice signals, and you're actually using quite a few of them. Might not realize it, but you're using quite a few of them, whether you're making a phone call from your house or cell phone, whatever. A lot of times your voice is getting packetized and sent through that network as little voice over IP packets, if you will. The reasons for implementing voice over IP, again, this was conversations that were had for many companies like 20 years ago of like, hey, why are we going to do all this? Why are we going to invest in these IP phones and this IP PBX? Why are we going to invest in this? And these were some of the reasons. You could do, again, we were showing two networks converging into one, and actually they called that network convergence for quite a while. I got rid of the actual phone network and moved the phone traffic onto the data network. You get some new advanced features. Again, think about today, I can browse into my phone mail system at Hack and look at my phone messages and even listen to my phone messages and turn right around and reply to them, even when I'm sitting at home. And during the pandemic, this was critical for a lot of companies to be able to adapt or use all these features if they hadn't had them in place. And again, I can have central voice and data management. I can literally have all that equipment on one network that we're managing, maintaining, backing up, supporting power for, etc. Instead of having two separate networks of equipment. So the types of configurations. Well, we had traditionally analog phones. We have IP phones now, and many people even have soft phones now. So let's talk real quickly about these three: analog, IP, and soft phone. Your analog phone is your traditional phone that you would have that would send and receive analog voice messages. My voice. IP phone is set up to specifically take my voice, packetize it, and send it through a data network. And the same idea as with my soft phone, but my soft phone is software installed on it could be a laptop, could be a desktop, it could even be on my smartphone. I can install a soft phone on my smartphone and have that to connect to my voice messages at my company or my place of work, which again, a lot of people do. I have that soft phone installed on my phone that I can connect to Hack's voicemail system, retrieve my messages, return phone calls, etc. So let's take a look at these real quickly. To do this, we need to recognize a term called a codec. Codec is a coder-decoder. This is a way to take analog voice and turn it into a digital packet to go across the network. So codec is going to encode an analog signal, compress it potentially, and send it across a digital network. The two common codecs we run into are G711 and G729. I mention these because as we do IP phone networks, you're going to see these, especially as we packet capture. You're going to see these, especially as you packet capture. So as we're doing packet captures, we're going to be looking for the G dot number, and that lets us know how is this network processing these phone calls. So the G711 came out in 1972. This was a way to just take my voice, sample it, and send it as data packets. So this is pulse code modulation. It is straight analog to digital conversion. And what it did was, here's your voice signal, it's a sine wave. What it does is it takes 8,000 samples per second and turns them into an 8-bit number. Each one of those samples into an 8-bit number. So my human voice range is roughly 0 to 4,000 hertz. And there was some research done on, I think that's the Nyquist theorem, on the best sampling rate for the frequencies you're sampling. And it found out, I'm pretty sure it's the Nyquist theorem, said for a 4,000 hertz range, I'm going to sample 2 times that. So I need to do 8,000 samples per second to get a good representation of the original signal. So 8,000 times a second, it looks at the amplitude of the signal and turns that amplitude into an 8-bit number. 8-bit number, 8-bit number, 8-bit number, 8-bit number. So it literally is taking samples and churning out a little byte of data to represent the amplitude. And the receiving end takes those amplitudes and kind of replots them on a piece of paper, so to speak, and can connect those together to recreate the original analog signal. That is your G711. It's straight analog to digital conversion. In early days of IP phone, this was a lot of bandwidth. 64K, oh my goodness, that's a lot of bandwidth. So initially, this was like a lot of strain on your network. So a lot of networks didn't use this initially because it was too much bandwidth. So some adopted the G729. G729 does a form of, and I'm using air quotes here, compression. It actually uses less samples per time by doing code-excited linear prediction, speech coding. It actually was like predicting what sounds were going to come and turning those into 8-bit numbers, lack of a better term. So you could have an 8-bit data stream versus a 64-bit. 1/8 the bandwidth got used. So a lot of early phone systems adopted this one, but it did require the use of a license fee because you had to pay for the right to use that special encoding, that special codec. So some early IP phone networks adopted that to save bandwidth for all the data traffic. Modern day, most networks have so much bandwidth that they don't need to use that, comparatively speaking. So G711 is a lot of times used now on networks because you have a lot of bandwidth to do that, and you can do some quality of service. Well, if I had an analog phone, I had a couple ways I could connect this up. Again, this was kind of like traditionally how we're going to migrate our analog phone system into IP phone. Well, one of the ways is you could do an ATA, analog telephone adapter. This allowed you to take your phone, plug it into this little box, and this is a modern one. This is one you can buy right now. I could plug my phone into here, and then this would convert, using that codec, to a digital signal to my network card into my network. And this could then talk to my IPBX as an IP phone, and away it goes. So I could take existing phones, plug them into these little bricks, and I wouldn't have to buy new phones. I would just need to buy these adapters. Okay, that would be one way I could take my analog phones and adapt them into an IP phone network. Another one is actually having a voice over IP router or gateway. Some people actually have these in their house now, and they're maybe just not aware that that's what it is. So if you have a regular phone in your house and you still make phone calls through like your data connection, whether it be Fios or Comcast or whatever, this might be built into your equipment somewhere that takes your analog phone that you have, converts it into a digital signal, and away it goes. So it might actually be a phone port built into your router, or the equipment from your ISP that's installed in your house. Mine, I still have an analog phone. It plugs into this type of unit in the basement before it goes to the fiber network. And there is even a battery in there to power my phone in the event of a power outage. So there's a backup battery in there to power that as well. So this kind of thing is built into some people's connection at home. The third method was literally to connect this to an IP PBX, and you can actually install cards into an IP PBX. This actually snaps into like expansion slots in the server, and I can plug a phone line directly into here. And it could be a phone on my desk, or it could actually be a phone line from the phone company that I plug in there to route calls in and out. And I even can snap in larger cards that would handle 24 phones in a business. So again, if we had all this existing equipment, I could buy a card and just plug those into the IP PBX. And that's actually where the name Asterisk comes from, the Linux-based phone server. Asterisk is a wildcard. When you do Linux, Asterisk is a wildcard that you use. The name of the Asterisk phone server, Asterisk, implies anything can connect to it. Yeah, as long as you buy the cards and snap in, pretty much anything can connect to it. That's where that the phone server IPBX Asterisk comes from. And this is one of their little sales diagrams showing that I can actually have this server interface with just about anything. I might need to buy cards to do it, but it can interface with just about anything. When I deal with IP PBXs, I can have an on-premise solution, meaning I literally have my own server on premises that everything connects to and routes through, and I maintain it. Or I can have a hosted service. Think back to our virtualization cloud computing chapter. I can have a virtual server out there that I'm routing my traffic to, or I could have this hosted by somebody, and I literally just browse in and start adding phones. Here's Bob Smith, here's Sally Smith, and literally just add the phones, and the traffic gets routed to it and processed. So with IP PBXs, there's a lot of flexibility now for managing my phone system. Okay, we'll come back in the next one, talk IP phones.